Our planet is a wonderful place. It's a vibrant, living world, teeming with life in its every corner. From the deepest oceans to the highest mountains, nature orchestrates a symphony of breathtaking complexity. We, as a species, have built our civilizations upon this world, often believing we are masters of it. Yet the Earth holds a power that we can scarcely comprehend. Did you know that a single volcanic eruption can release more energy than all the nuclear weapons on Earth combined? It's a humbling thought. We are not separate from nature, but a part of it, subject to its immense and sometimes terrifying forces. We often live with a sense of permanence, believing they will stand for centuries. On a handful of occasions, our intricate world has been brought to the very brink of collapse. In this exploration, we will journey back to some of these pivotal moments. This is the story of our survival. In April of 1815, on the small Indonesian island of Sumbawa Mount Tambora, a mountain exploded. It was the largest volcanic eruption in recorded human history. It ejected enormous quantities of ash, rock, gas high into the stratosphere. Sulfur dioxide rose into the upper atmosphere and formed a vast aerosol veil around the globe. They reflected sunlight back into space. Global temperatures dropped dramatically. The year that followed, 1816, became known as the year without a summer. Summer frosts killed crops in Europe and North America. Snow fell in June, rivers froze in July. Widespread crop failures led to famine. Food prices skyrocketed, leading to riots and social unrest. People were starving, desperate and confused. In a world not yet connected by fast information, people adapted. Farmers planted hardier, cold-resistant crops. Communities shared what little they had. The shortage of oats for horses inspired Carl Drace to create a precursor to the modern bicycle. In the gloomy, rain-lashed summer, writers gathered, and Mary Shelley conceived Frankenstein. Out of the darkness came resilience, and even a spark of creativity. It was a stark lesson in how a single, powerful event in nature could destabilize societies across the world. The sun is the source of all life on Earth, but our star is also a dynamic and sometimes violent celestial body. In September of 1859, Richard Carrington witnessed an intensely bright flash erupt from the sun's surface. A colossal solar flare hurled a gigantic cloud of magnetized plasma toward Earth. It covered 150 million kilometers in just over 17 hours. When it hit Earth's magnetic field, the results were spectacular and terrifying. Telegraph systems, the pinnacle of communication then, went haywire. Operators received shocks. Telegraph paper caught fire. Imagine the Carrington event happening now. It could overload and destroy power grids across continents. It would cripple satellites, silence global communications, and knock out GPS navigation. Financial systems would freeze. We'd be plunged into technological darkness for years or decades. The 1859 event was a warning shot, a glimpse of a vulnerability we'd later create. For many at the time, the main global effect was breathtaking auroras. Today, scientists see it as a crucial benchmark, a reminder our star can switch off the modern world in an instant. We now monitor the sun constantly and develop strategies to protect infrastructure, giving us a precious window to prepare. On the morning of June 30th, 1908, a remote region of Siberia experienced an event of cosmic proportions. A fireball brighter than the sun blazed across the sky. Minutes later, a colossal explosion erupted in the atmosphere about 5 to 10 kilometers above the Earth's surface. The blast flattened an estimated 80 million trees over more than 2,000 square kilometers. The shockwave was registered by seismic stations across Europe. For years, its cause remained a mystery, sparking speculation. Today, consensus points to the airburst of a large meteoroid, a fragment of a comet. What is truly terrifying is the element of chance. Had the object arrived a few hours later, the Earth's rotation could have placed a major European city directly in its path. The result could have been a city utterly annihilated, with loss of life in the millions. Because it occurred in a remote area, the human cost was relatively small. Eyewitnesses described a split sky and great fire. The first scientific expedition did not reach the site for nearly 2 decades. Tunguska demonstrates our vulnerability to space debris. Randomness and scale mean our survival can hinge on hours of planetary rotation. Sometimes the greatest threat from nature is not its direct power, but its ability to confuse our own creations. On September 26, 1983, the world was balanced on a knife's edge. The system reported missiles, one, then a second, then a third, and more. Protocol demanded immediate escalation. Lieutenant Colonel Stanislav Petrov faced an impossible choice: The fate of billions rested on the judgment of one man. To launch a counterattack on that data would have been madness. He reported the alarm as a system malfunction. He was right. Later investigations showed satellites had mistaken sunlight glinting off high-altitude clouds for missile plumes. A quiet officer who trusted human instinct over instruments saved us from ourselves. The incident shows the danger at the intersection of nature's unpredictability and our own destructive technology. One human decision prevented a chain reaction. Over 150 years after the Carrington event, our reliance on technology had grown exponentially. Our world is now woven together by an invisible web: electricity and data. In July of 2012, this entire global system faced a threat most were unaware of. A gigantic cloud of plasma, even more powerful than the 1859 Carrington flare, erupted from the sun. The eruption occurred on a part of the sun not facing Earth. The cloud tore through Earth's orbit, and we weren't there. It had passed that point in space just 1 week earlier. We dodged a cosmic bullet by the narrowest margin. Had it hit, transformers could be fried, plunging continents into darkness for months or years. Clean water, refrigerated medicine, communications and transportation, all at risk. The 2012 near-miss accelerated research and the development of protective strategies. Now we have a precious window. Time to power down sensitive grids and put satellites in safe mode. It was a stark, silent warning. The threat from a Carrington-level event is a clear and present danger. We survived by luck. We cannot rely on luck forever. We must be prepared. On the day after Christmas in 2004, the Earth itself moved. A section of the crust over 1,000 kilometers long suddenly ruptured, a megathrust earthquake. The seafloor was uplifted, displacing an immense volume of water and generating waves that raced across the ocean. The waves moved outward silently and with incredible speed. They struck the coastlines of 14 countries, from Indonesia and Thailand to as far away as Somalia. In many places there was no warning. Coastal communities were caught completely by surprise. Waves over 30 meters high swept ashore with unstoppable force, obliterating everything in their path. Entire towns were wiped from the map. The human toll was staggering. Nearly 250,000 lives lost. The tsunami revealed a critical weakness. The Indian Ocean lacked a coordinated warning system. The scientific knowledge existed, but not the infrastructure to get warnings to vulnerable people. A massive international aid effort followed. The event became a catalyst for change. In the years that followed, a sophisticated Indian Ocean tsunami warning system was established. Deep ocean buoys, seismometers, and communication channels to alert coastal communities. The most recent threat to our civilization came not from the Earth or the Sun, but from something invisibly small. A novel coronavirus emerging in late 2019 spread with breathtaking speed across our interconnected world. The pathways of global trade and travel became conduits for the virus. Hospitals were overwhelmed, supply chains broke, economies were shut down. The pandemic revealed shocking fragilities in healthcare, supply chains, and economic models. But we also saw the power of global scientific collaboration and rapid vaccine development. We rediscovered community and the vital role of essential workers. We also saw the dangers of misinformation and divisions that can hinder response. The pandemic was a live fire exercise, a lesson in learning, adapting, and investing in public health infrastructure and transparent communication. Looking back at these near disasters, clear patterns emerge. We see unpredictability, scale, and our own fragilities. First, stay informed. Do I know the primary natural risks in my community? Second, have a plan, a meeting point, and an out-of-state contact. Third, build a kit. Water, non-perishable food, first aid, flashlight, radio. Fourth, know your neighbors. Community is our first line of defense. Resilience requires foresight, investment, and cooperation. It is a shared duty. Small acts of foresight taken by many weave a stronger social fabric. The Earth is, and always will be, a place of magnificent and powerful forces. The question for our generation is, have we listened to the warnings? Are we ready for the next one?